Another method in order to solve systems of equations is by substitution. With substitution, what you're going to do is you're going to have two different equations in which you're going to plug something into the other equation in order to get your solution. So for instance, if I have x minus 2y equals 1 and x plus y equals 4. So what I'm going to do is I'm going to get a variable by itself. I'm going to work with the right side equation. I've just got 1x and a 1y, so that one's just a little bit easier to work with. But your goal is to find an equation in which the coefficient to your variable is 1. So technically the left side would work as well, just because it's a 1x there. But like I said, I'm just going to work with the one on the right. I'm going to go ahead and solve for x. So that means I'm going to subtract the y from both sides, in which I have x equals negative 1y plus 4. So now that I have an x equals, or if it was a y equals, it doesn't matter. I'm going to take what that x equals and plug it into, or substitute it into that x spot. So I have now in the x spot negative 1y plus 4 minus 2y equals 1. So now I don't have that double variables there. I only have one variable in which I can solve for that variable. So negative 1y minus 2y gives me negative 3y plus 4 equals 1. I go ahead and solve for y. So negative 3y equals negative 3. Y therefore equals 1. However, I need to still solve for the x value. So now that I have a y equals some value, I can take that and plug it back in order to solve for x. So x equals negative 1 times y, or times y, times 1 in our case, because that is our y, plus 4. Therefore, x equals negative 3. This can get kind of tricky every now and then, depending on do you have a true variable that has a coefficient as 1? Sometimes you might not always have that, so you're going to have fractions in which you're going to have to deal with stuff. There is a potential where you could have a no solution, or you could have a infinitely many solutions. And when that happens, when you get to, I'm just going to highlight here what step I'm on. When you get to like this step where you're combining your like terms, what happens is you actually eliminate, now granted this isn't going to work for this equation, but you're going to eliminate your variable altogether, and then you're left with this 4 equals 1. Well, how often does 4 equal 1? Well, never. So that's going to be a no solution. However, if it was like a 4 equals 4, then it would work out that you would have infinitely many solutions, because we know 4 equals 4 always. I'm still going to go through another one just as good measure, but just wanted to highlight to you that there are times when you can have a no solution or an infinitely many solutions. Last example here. And because I know you guys love fractions, and of course I didn't give you one with a coefficient that was by itself. That would have just been too easy. So with that, I'm going to go ahead and solve for a variable. I'm going to work with the one on the right. I don't know, I just kind of like the right side. In this case, the 2 is smaller, and so when I'm thinking about fractions in that case, I'm dividing by 2, and those fractions are a little bit easier to work with. because you can change those into decimals so that it's just a 0.5. Like I said, it's just easier to work with when you have a 2. So I'm going to add the 10y over. I've got now 2x equals 10y minus 11. I'm going to divide by 2 to every component. So x equals 5y minus, like I said, I'm just going to change this to a decimal, 5.5. So now I'm going to take that value and plug it in. So now I've got 4 times, leave that blank for right now, plus 6y equals negative 9. So now I can plug that in. So it's 5y minus 5.5. So I now have 20y minus 22 plus 6y equals negative 9. Notice it worked out there that I don't have a decimal anymore. So now I've got 20y plus 6y gives me 26y minus 22 equals negative 9. We're going to add that 22 over. 26y equals 13. Divide by that 26, and I get a half. Or 0.5, I don't care which one. So now that I've got my y value, I'm going to have to take that and plug it back in. So now I've got x equals 5 times, put parentheses there because I'll plug it in, minus 5.5. I've got a half that goes in there. I can just type this right into my calculator, and I'm going to get negative 3. So with substitution, sometimes it's a little bit easier than graphing, because if you notice at the very beginning of this problem in particular, both equations here are in standard form, which means that I would have had to rearrange both equations in order to graph them. Same thing over here. I would have had to rearrange both equations in order to graph them. So there are times when it's easier to graph, and there are times when it's easier to use substitution.